Hello, my name is Kim Sauer at Apex 2015 in San Diego. I'm joined today by Jeff from Parmy. Jeff, good to see you here.
Good afternoon. It's nice to be here.
Absolutely. Let's talk about Parmy and what's going on there. What's
Great.
new?
Well, first thing for us this year, we are the proud recipient of the New Product Introduction Award for the third year in a row.
Congratulations.
For our Sigma X SPI system.
Yeah.
And the feature that put it over the top this year was an integrated jet dispenser. So what we've done is we've taken solder paste jet dispensing, built that into the SPI machine. So after we've inspected a board and we identify pads on the board that have insufficient solder paste, we use the jetting system to go in and add more paste to pads that need it, re-inspect the board, and then send the board down the line completely reworked. So that's a first, and you won't see that anywhere else in the show hall, and it's an absolute showstopper. So that's type 6 solder paste, and we're jetting paste sizes of 200 to 250 micron. So we eliminate rework, eliminate scrap, and that's a big profitability boost for our customers.
So it's cost savings, it's speeding up the whole process as well then?
Yeah, it increases your capacity because it's giving you more good boards per hour.
Yeah.
And it's reducing the amount of rework you have because we're repairing those boards right inside the SPI machine. Yeah. And we're doing it in real time. So we inspect the board, find the defect, fix the defect, re-inspect it, and then send the board down the line. So it's a real clean process.
Are you finding that that sort of solution is particularly interesting for certain industries, or is it relevant to everybody out there?
Well, that's a great question. I don't think that jetting solder paste is the right thing for everybody. But one of the challenges that our customers face today is designing stencils for very, very small components, and at the same time having designed that same stencil for very large components. So you have the need to put very small deposits down adjacent to very large deposits. That makes stencil design very, very difficult. So you start to get close to aspect ratios and violate those aspect ratios, and it affects your print performance. So having the ability to repair those insufficient pads in the machine really opens up that window for you so you have more room to play with. So I think if you have an application that has a wide variety of component types and pad sizes, it really plays into your hand. But everybody has the problem with rework costs. Everybody in the industry seems to agree that the majority of defects that are created on the line can be traced back to the screen printing process. And then if you dissect and break out the type of defects at the screen printer, you find that insufficient paste on pad is the leading culprit. So if we can eliminate that, we're eliminating 50% of your printing issues within the SPI machine. Yeah. So that, SPI machines have really kind of struggled over the years to prove the return on investment. But when you start to incorporate features like the jet, you can really quantify how much rework savings you have. And then we also have other software called the Printer Doctor that correlates inspection results back to activities in the screen printer. So our SPI machine can actually tell you when your board support tooling isn't right, if you have a damaged or nicked squeegee blade, if your paste is too cold, it's not ready to print. And those are features that are only available from Parmy. So those are real differentiators and game changers.
And that's sort of addressing a lot of trends that we're seeing going on the printed circuit board side. So miniaturization, complexity of board, density of board, all of those aspects that then potentially can create more problems. You're ticking those boxes.
Absolutely. I mean, people often ask me, what are the toughest boards you guys see and work with? And they think I'm going to answer and say, well, it's those great big boards that have 50,000 pads on them. It's not. Oftentimes, those are the easiest boards. The toughest boards are the ones you have in your pocket, the cell phone, the simple, complex cell phone with very, very small passive devices, very I/O-rich smart devices, cans on there for RF. You have in your phones today, you have a camera, you have video, you have GPS, you have mass data storage, you can watch a movie. There's a lot going on in what we think about as a simple but complex cell phone board. The other thing you have going on is you have a lot of customers that have spent millions of dollars to build up these great lines, they don't have a need for additional capacity to build more good boards per hour. What they want to do is get more efficiency with the lines that they have. So a really good investment are some really smart, good inspection tools like a Parmy SPI or probably others that allow you to improve your yields. And if you improve your yields, you're reducing rework, you're reducing scrap, you're clearly increasing your capacity and you're increasing your profitability. So if you have $1 million, multi-million-dollar line for around $100,000, you could boost your yields by 2, 3, 4%. And in actual profitability dollars, those are hundreds of thousands of dollars, if not millions, at the end of the year. So definitely a trend to try to take a customer's line the way it sits today and try to improve the efficiency so overall you can gain more capacity and more profitability.
And then ultimately, probably it also fits in with the developments that are going on within the smart factory space, that whole traceability aspect of a manufacturing line.
Well, we live in a data age,
yeah,
right? And I've been in the industry for 30 years, and if you looked at what your hopes and dreams were 20 years ago in a machine or 10 years ago, you thought that some of those things were a dream, and would they ever come true? And as you walk around the show floor today, you find out that we're communicating out of these machines in standard formats today. So you can use other software tools to pull in that data, analyze the data, and help you get better at what you do. So I think the things that we were dreaming about 10 or 20 years ago are now actually living and in fruition, which is great. Now we have to take it to the next step, and those are the kinds of things we're doing with like the Printer Doctor and embedding a jetter inside of something. And then we'll have to see what the next great invention is. So we're working on that.
Excellent. So lots of great success ahead of us, lots of R&D ahead of us. It was great talking to you.
It's a pleasure. Thank you very much.
Thank you very much for your time, Jeff.
My pleasure. Thank you very much.